All right, let's get right into it. Today, we're tackling a choice that every single person who works with metal has to make, and it can absolutely make or break your project. We are putting two absolute heavyweights of the steel world head to head. The everyday workhorse 1018 versus the toughest nails powerhouse 4140.
And look, let's be real. This isn't just some abstract comparison. Picking the wrong steel, well, it can mean total project failure. We're talking wasted money, hours of frustration, and parts that just don't hold up. But if you get it right, oh, that's when you get something that's built to last. So the big question is, how do you actually decide?
Okay, to really get to the bottom of this, we're going to frame it as a tale of two steels. Because that's what they are. These aren't just random numbers on a spec sheet. They're two completely different contenders, each with its own personality, its own strengths, and its own purpose.
So first up, let's meet 1018. If you've ever worked in a shop, you know this stuff. It's the reliable workhorse. It's a simple low-carbon steel, which makes it super versatile, incredibly easy to work with, and maybe most importantly, it's easy on the wallet. For most general-purpose jobs, 1018 is the default, the go-to, the old faithful. And then, in the other corner, you've got 4140. This is the powerhouse. This is the specialist you call in when things get serious. It's a medium carbon alloy steel, and it's got some secret ingredients, chromium and molybdenum, that give it just immense strength, hardness, and durability. You use this when failure is simply not an option.
So, let the matchup begin. For round one, we're talking power versus practicality. We're going to look at the raw numbers, the core mechanical properties that really define what these steels can physically take before they bend, break, or give up. We're talking strength and hardness.
And wow, these numbers right here tell a really clear story. Let's just quickly break this down. Tensile strength, that's the absolute maximum pulling force it can take before snapping. Yield strength, that's the point where it stops springing back and starts to permanently deform. And Bernal hardness, that's just a measure of how well it resists getting dented. And you can see in every single category, 4040 is just on another level. This chart just says it all, doesn't it? I mean, look at that massive gap in tensile strength. 4140 can handle so much more force before it fails. So if you're building something that's going to be under a lot of stress, think axles, gears, anything that needs to be incredibly tough, there is no contest. Round one, without a doubt, goes to the powerhouse 4140. But hang on, pure strength isn't the whole story, right? A super strong material is kind of useless if you can't actually make anything with it. So that brings us to round two, the making and shaping. This round is all about a really practical question. How easy is this stuff to actually work with? And this is the great trade-off. See, all that strength you get from 1440, it comes from having more carbon and those special alloys, and that makes it harder to cut and way, way harder to weld. But 1018, with its simple, low-carbon chemistry, is an absolute dream to fabricate. It machines like butter, and you can weld it with pretty much any standard process. No fuss, no special prep. Just to put this in perspective, check out the hoops you have to jump through to weld 4040 correctly. You've got to preheat the whole piece to stop it from cracking from the temperature shock. You need special low-hydrogen electrodes, and then, when you're all done, you have to do another heat treatment to relieve all the stress you just put into it. It's a serious, skilled process. So for ease of making stuff, round two is a knockout victory for our workhorse, 1018. Okay, so it's 1-to-1. We have a powerhouse and a practical workhorse. Let's head into the final round, the real-world test. This is where we look at the long game. How do these steels actually hold up over time, especially in tough conditions? And of course, we have to talk about the bottom line. How much does this stuff actually cost? So in the durability department, those special ingredients in 4140, the chromium and molybdenum, they give it another real edge. It's naturally better at resisting rust, whereas 1018 will start to corrode pretty darn quick if you don't coat it. And even though both can handle some heat, as things get really hot, 4040 does a much better job of holding on to its strength. But then we have to talk about the price tag. And this is where 1018 lands a massive counterpunch. Because it's a simple, mass-produced carbon steel, it's incredibly affordable. 4140, on the other hand, with its pricey alloys and more complicated manufacturing process, can easily cost 3, even 4 times as much per pound. And that's not a small difference. On a big project, that can be the deciding factor for the entire budget.
So we've laid it all out. We've seen the strengths, we've seen the weaknesses. One is incredibly strong but a pain to work with. The other is easy to handle but just can't take the same punishment. So let's bring it all together and figure out how you make that final call for your next project.
Okay, this right here is basically your cheat sheet. It really is this simple. If your project involves a lot of fabrication, a ton of cutting, welding, bending, and you've got to keep an eye on the budget, 1018 is your champion, no question. But if the number one absolute priority is brute strength, hardness, and the ability to resist wear and tear in a really high-stress situation, then you got to open up the wallet and invest in the power of 4140.
So what's the big takeaway here? Choosing between 1018 and 4040 isn't really about picking the stronger steel or the cheaper steel. It's about deeply understanding what your project actually needs. Knowing what these materials can do, well, that's the science. But knowing why you should choose one over the other for a specific job, that, my friends, is the real craft.